In this lesson, we're investigating how to titrate using diprotic solutions. Our lesson objectives: calculate the concentration of unknown solutions following a titration reaction with a diprotic solution. So recall that a neutralization reaction occurs when the hydrogen ion, or proton, and our hydroxide ions combine together, and so a 1-to-1 ratio is needed to make water, H2O. But if an acid or base has more than 1 mole of these ions, it's going to require twice as much of the other ion to neutralize it. So we can use our titration formula, the MAVA equals MBVB, but in front of the concentration of the acid and the concentration of the base, we can put the number of moles of ions that are produced. So for example, if we're going to titrate using H2SO4, this is a diprotic solution because it produces 2 protons, 2 H+ ions. And so for every 1 mole of H2SO4, we're going to get 2 moles of our hydrogen ions. So when we start to titrate and neutralize our acid with our base to form water, what's going to happen is it's going to require twice as much of our base in this situation to neutralize our acid. So let's look at an example using a titration for a diprotic solution. So what is the concentration of a solution of H2SO4 if 30 mLs of H2SO4 is titrated to completion with 35 mLs of 1.5 molar sodium hydroxide? So first we're going to write our formula, and we recognize now that it's a diprotic acid here, H2SO4, so we're going to account for that by putting a 2 out in front of the concentration of our acid. We have the volume of our acid. We're solving for the concentration of our acid, that's Ma. We have the volume of our base, and we have the concentration of our base. And so when we plug it in, it's going to look just like this. So again, the 2 out in front of the concentration of our acid, indicating that we have a diprotic solution here. We're solving for the molarity of our acid, and everything else is filled in. And when we solve, we get a concentration of the acid to be 0.88 molar. So we used a 0.88 molar solution of H2SO4 to neutralize 35 mLs of our 1.5 molar sodium hydroxide. Okay, now let's try one together. Given 15 mLs of a 2 molar H2SO4 solution, what volume of 3 molar sodium hydroxide is required to neutralize the acid? So first figure out what are we solving for. So we're solving for the volume of our base. Then we check and see, are we using a diprotic solution? And the answer is yes, we have H2SO4. We're going to write out our formula, and the 2 is going to go in front of our acid, and then we're going to plug in our values, and then when we solve, we get an answer of 20 mLs of sodium hydroxide. Okay, lastly, now you try one on your own. If 5 mLs of a 2 molar H2SO4 solution is required to neutralize exactly 10 milliliters of sodium hydroxide, what is the concentration of the base? So the first thing you're going to do is use our titration formula again. We recognize a diprotic solution here. We have H2, so the 2 is going to go out in front of the concentration of our acid. And we plug in the rest of our values as we see here. And when we solve for the concentration of our base, we get an answer of 2 molar sodium hydroxide. Let's check your understanding. Can you calculate the concentration of an unknown solution following titration reactions with a diprotic solution? At this point, you should be able to calculate the concentration of an unknown solution following a titration reaction with a diprotic solution.